This is another problem related to super mesh. So in this problem the question is saying that find the mesh currents for the given circuit. Now we can see here there are two mesh. So quickly we will just write the mesh here. So I will consider this as mesh 1. So that is the current flowing here is I1, and let us consider this as mesh 2, and current flowing here is, let us take I2. Now you can see here there is a dependent source here. So this one is the dependent source here, and this dependent source is common to mesh 1 and mesh 2, and because of that what we can do, so we have to apply super mesh for mesh 1 and mesh 2. Why? Because the dependent source given here, it is common to both mesh 1 and mesh 2. Now if we write the mesh equation taking this mesh 1 and mesh 2 as super mesh, we are forming one new mesh which is a big loop. So what we will get? So 20 minus 4 I1, right, minus 6 I2, because I2 is flowing in the 6 ohm resistance, minus 2 into I2, that is equals to 0. Okay. So we can solve this also. So here it is 4 I1 minus 6 minus 2, that is 8. So it will be 20 minus 4 I1 minus 8 I2 is equals to 0. Let us this is consider this is equation number 1. So next is what is given in the circuit. So the value here, what is the current flowing here. So if I take this as a node, let us say node A, so I can write here at node A. So what is happening, I can apply the KCL. So if I apply the KCL, we know that one current is going here as I1, one current is coming inside as I2, so this is I1, and one current is going here, and that value is Vx divided by 4. The current value here is Vx divided by 4, because this is a dependent source, and like this the voltage is given. So you can see here these two currents are outgoing and this is incoming. So we can simply write here as per KCL, I2 is equals to I1 plus Vx divided by 4. Okay. Now what is the value of Vx? So value of Vx is, you can see, given here. So Vx value is the voltage drop across the 2 ohm resistance. So we can write then at across 2 ohm resistance, what will happen? We have Vx, that value is equals to how much? V equals to I into R. So 2 is the resistance and current flowing here is 2. Okay. Now let us say this is equation 3 and this is equation 2 and this is equation 3 here. Now what we can do? So using equation 3 in equation 2, what we will get? I2, we know the Vx value now. So I2 is equals to I1 plus Vx value is 2 I2. So 2 I2 divided by 4 here. Okay. Next, if I simplify this again, then what I will get? Your I2 value is equals to 2 into I1. So just simplifying this, I will get this thing, I2 equals to 2 into I1. Now let this be equation number 4. Then using equation 4 in what? In equation number 1. So in this equation, if I use this, the value of I2 is 2 I1. So this equation can be written as 20 minus 4 I1 minus 8 into 2 I1. Okay, that is equals to 0. Now if I solve this for I1, so what we can get? So here it is 20 minus 4 I1 minus 16 I1 is equals to 0, and here it will be 20. So I1 value will be equals to 1 ampere. So this is the mesh 1 current. Now here we know we can directly write what is the value of mesh 2 current from here. Your I2 will be equals to 2 into 1. So that implies your I2 is equals to 2 ampere. So this is 1 ampere and this is 2 ampere. So these are the two mesh current that we can get from the super mesh analysis. In the next video I will be discussing one new problem.